Hello, class. Today, we are going to be working with a statistical element called the z-score. The z-score is how many standard deviations from the mean a piece of data is. To recap, so far, we have learned about three measures of central tendency, namely the mean, the median, and the mode. The mean is the average, where we add up all elements together and divide by the number of elements we added. But if there is an outlier like this, the mean isn't the best representation for the data. The median is the middle of all elements when they're put in numerical order. If there is an outlier, this still shows the basic middle of the data set. Lastly, the mode is the most common element in the data set. The standard deviation is how precise the data is, or, as I like to say, how far the data deviates from the mean. So if we start with the data set 2, 4, 5, 6, and 8, we must first find the mean of this data, titled x bar, in order to see how the data deviates from this mean. The mean is 5, and so we find the difference between each piece of data from this mean, labeled as x minus x bar. Then we take x minus x bar and square it. Notice how each element in this column is positive because all squares are positive. This means you don't need to worry about positives or negatives when finding x minus x bar. Next, we find the sum of these. In this case, the sum is 20, and we divide by our n, which is 5. Last step for finding the standard deviation is to take the square root of this number. Remember that we squared the data here, so we want to undo that here. So our standard deviation is 2, which means that, on average, our data deviates from the mean by 2. In a moment, we will see how we use this number. But first, let's see how this standard deviation compares to other data. This group of data is small and near each other. What if we had data which is more spread out, like this? If you follow the same steps, we see that the standard deviation is larger, which tells us that the data used is more spread out. Now for what to do with the standard deviations. The z-score is how many standard deviations from the mean a piece of data is. For this example, we will use the intelligence quotient, commonly referred to as the IQ score. The average human's IQ score is 100, with a standard deviation of 15. When it's drawn out on this number line, the mean of 100 goes in the center, and each adjacent line will be labeled with the next increment of 15. But what about the bell curve above? This represents the density of the population who fall into this region. Between the mean and one standard deviation up, there lies 34% of the population. That means that 34% of the population have an IQ score between 100 and 115. Likewise, on the left side, 34% of the population have an IQ score between 85 and 100. The next increment holds a different percentage. Do you see how the graph is thinner here? The percentage between the next two lines is only 13.5%, and the same on the left side. Do you see how everything is split evenly? That's definitive of a normal distribution curve. Considering that everything is evenly distributed, can you guess what percentage is beyond 2 standard deviations? If you said 5% or 2.5%, you are right. The total curve adds to 100%, and so each half adds to 50%.